Hi guys, it's Miss Perry. I hope you guys had a great spring break. You stayed inside and were safe, or you got some good stuff done, like you know something besides homework. And so what we're going to do right now is I want to move on to section 12.4, colligative properties. Okay, so a solution, the properties of a solution depends on the solute, on the substance that's dissolved. But a colligative property is when the properties depend on the concentration of your solution. So if you have more solute than dissolved in it, then you would have different properties. And some of the properties we're talking about are boiling point, freezing point, and osmotic pressure. So there's something called boiling point elevation, and that's just when the normal boiling point of a solution is raised. So the boiling point of salt water is higher than pure water. So this is just if based on the concentration of a solution, the boiling point can be higher. And the more concentrated the salt water is, the higher the boiling point will be. So if it's not very concentrated, then it won't be as different as if you have really very, very concentrated salt water. Okay, now freezing point depression is the opposite. If you have the normal freezing point of water and you put salt in it, dissolve the salt, then the freezing point is lower than regular water. And again, the more concentrated the solution, the lower the freezing point. So it is all key on how concentrated your solution is. Now, to see a demo of freezing point depression, I have a link in the description for a Chemistry Matters video. You only have to watch it up until I think it's 6 minutes and 27 seconds. We will not be doing the calculations. I just want you to see kind of how it works. They're doing an ice cream activity that you are welcome to reproduce at home, and I have put that on the on RenWeb for you. I believe I said that it is a 5-point bonus activity, and that's explained on RenWeb. Okay, so then we have something called electrolytes, and you've probably heard about this from like sports drinks that that replaces your electrolytes. So all that electrolytes are compounds that dissolve in water to produce ions. And if you have a good concentration, then you can actually conduct an electric current. So you have strong electrolytes and weak electrolytes. So strong, you have only ions, and it maintains a good, strong electric current. And an example of that would be salt water. Weak electrolytes don't have very many ions, and it has very poor current flow, so it's not a really good conductor. And an example of that is acetic acid. Then you have a non-electrolyte where there's no ions, and it's a poor conductor. So if it's a poor conductor, then you don't have any flow of electricity, and that would be a sucrose solution is a good example, and that's sugar water. Okay, osmosis is when you have a solution that's passed through a semi-permeable membrane. You may remember this from biology, maybe, where we talked about cell membranes and how they're semi-permeable, so they let some things through and not others. And so that's one of our examples, the cell membranes, your skin, and things like parchment and cellophane wrap. Okay, so osmotic pressure is the pressure exerted on that membrane. So it only occurs when there's a difference in concentrations of the solutions on either side. So the solvent is going from the more dilute solution to the more concentrated solution. So if you have a membrane where you have very dilute salt water on one side and very concentrated solution of salt water on the other side, the solvent is actually going to flow, the water is going to flow from the side that's more dilute to the more concentrated side. And there's a really good example on, I've got the video linked below for Bozeman Science. They have a good channel, and he's doing a really good demo on osmosis. I think you'll like that. Now, go ahead and watch those 2 videos, and then do the questions 1 through 3 on page 216. And do that for me, and shoot me a text or an email if you need some help. Yep, that's it. All right, bye guys. Take care.